Let's take a look at how to solve this question. 2 times cosine x minus pi by 6 multiplied by sine x equals to sine x. Now, if you are thinking of expanding out cosine x minus pi by 6, bad idea. Very bad idea. You're going to introduce a lot of unnecessary terms because there is a clever trick that you can do in this question. Okay, let's just get on with it. So what you notice is that on the left side there's a something 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 sine x. On the right side you have sine x. Sine x and sine x. It's a common factor. So I can bring the sine x over to one side, right? So let's just do that. With my iPad I can do this trick. Okay, minus sine x. See? So fast. Don't need to write down. Don't have to copy and paste right down another line. Just click and drag and select the equal 0 over to the other side. Okay, so anyways, I managed to bring all my sine x terms onto one side. So now there's a common factor of sine x. So of course I can factor out the sine x, right? Multiplied by, okay, I just put brackets around it to be extra clear. Sine x multiplied by the first guy, you can factor. After you factor out the sine x, you'll get cosine x minus pi by 6. 2 cosine x minus pi by 6. Then the other guy, you have a sine x factor out, you'll get a minus 1. Oh, equals to 0. Oh, then you realize something multiplied by another thing is equal to 0. Just like when you're solving quadratics, like x minus 2 times x plus 3 equals to 0. What's the next line that you can write straight away? You don't tell me you don't know, you have to know this. It's simply the first factor equal to 0 or the second factor equals to 0. Then you can bring the constant over and solve for x. Bring the minus 2 over, become plus 2. Bring the plus 3 over, become minus 3. Sorry, there's an extra line here. Okay, yeah, minus 3, yes, okay. So that's how you solve a quadratic. Same thing here, but it's just that instead of having a x minus 2 and x plus 3, we have a sine x and 2 cos x minus pi by 6 minus 1. So let's just continue trying to solve it. What do we get? We'll get the first guy sine x equal to 0. Oh, what is going on? Right, my pencil was behaving weirdly. Let me just... Okay, come back. Yeah, sine x equal to 0, that's the first guy. Or it could be the other guy. The other guy equals to 0. Now, let's just take a look at sine x equal to 0 first, okay? The easy to solve one. Sine x equal to 0. Notice that the angle they gave in this question is a bit funny. Very funny. 0, x is in between 0 and 3 pi radians. So just now the part B was in degrees, now it's in radians. It's trying to trick you. Check whether you're reading the question or not. Make sure that your calculator, you change your calculator's mode into calculator mode, angle mode, into radians. Make sure it's in radians first. And because it's in between 0 and 3 pi, we need to do something a bit special. So I'll just explain as I go along, okay? Now, sine x is equal to 0. How do we solve for that? That's when this is not a problem that can be solved by a Emacs student. Only Amacs will teach you how to solve sine x equal to 0. So what you're supposed to do is to realize that the sine curve looks something like this. Oops, that's not very nice. Let me try again. Something like that, and the other half, the negative half. Oh, it's not half, it goes on forever. But we'll just draw a few cycles, then stop there. So when you have equal 0, it's basically asking you have a line y equals to 0. You have another black color curve y equals to sine x. What are their intersections? The intersecting points. This is like y1 equals to sine x. This is like y2 equals to 0. Then you're asking when is y1 and y2 equal? whenever they intersect. Whenever they intersect is when they are equal, which means that you're looking for this point, 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 this point. So there's infinitely many solutions. Oh, but that's why there's so many possible angles. Oh, by the way, the x-axis is really the angles. X represents angles, radians, in terms of radians in this case. So there's so many possible angles that I just highlighted. Right, this could be 0 degrees, this could be 180 degrees, 360 degrees. What's 360 plus 180? Some value, 540, right? Then you can just continue adding 180, 180. Just need to know that the gap in between is always 180 degrees. 180 degrees. To the left and to the right. So let's just list down some of the angles first, okay? Some of the angles. We definitely know that x equals 0 degrees is one of them. But we could also have plus or minus 180 degrees, right? Let me just use a different color so it's easier to see. Could plus 180 degrees or you minus 180 degrees. Or you could, from 0, you go and plus 360 degrees, minus 360 degrees. Plus 3 times of, this is 1 times of 180 degrees, 2 times of 180 degrees, 360, 3 times of 180 degrees, I can't remember, I think it's 540, 3 times 180, 540 degrees. And of course you can do it on the other side as well. Erase this because it's quite messy. Could do this at the other side as well. Minus 1 times of 180 degrees, minus 2 times of 180 degrees, minus 3 times of 180 degrees. Oh, yeah. So we can get all these angles. However, we only want. Okay, let's just continue. Let's just list down all the angles first. Plus minus 360, plus minus 540. A few of them. Okay, 540, what's another one? 540 plus 180 is 720. Plus minus 720 degrees. Okay. Now that's when you have to pause for a while and realize, wait, we wanted radians, not degrees. Okay, so we convert everything into radians. Okay, radians. Okay, that's my mistake. I forgot to change it into radians. We are talking about radians, right? So we'll have to convert into radians, no choice. 180 is pi, then 260 is 2 pi, then plus another 180 degrees. Oh, it just so happens that pi is 180 degrees, so plus 180 is the same as 3 pi, then plus another 180 is actually plus another pi. Wow, radians is so much easier only in this special case. Radians is so much easier. In this case, you just plus 5 plus 5, so easy. Don't even need to calculate 180 plus another 180 plus another 180. A lot easier. But in this case, what the question is asking you is for angles that are in between 0 and 3 pi. And notice is strictly less than. Oops. Yeah, strictly less than. Means that we cannot have angles that are exactly equal to 0, or exactly equal to 3 pi. So what we need to do is definitely those angles that are outside of 3 pi, out, cannot. Those that are negative, also out. Negative, out, cannot. We only want positive, more than 0, right? More than 0. 0 less than x is the same as x more than 0. Looks like a happy face. Looks like a face. Okay, anyways. Yeah, so what this means is that our angles, our answers have to be restricted down further. So maybe it's only x equals 0, pi, 2 pi, and 3 pi. But there's still something wrong. Do you know what's wrong? In this case, what is still wrong is that the 3 pi and the 0, they cannot be allowed. Why? Because again, it is 0 strictly less than x, and x strictly less than 3 pi. Means that the angles that are exactly equal to 0 exactly equal to 3 pi, we cannot accept them as answers as well. What this leaves us with is pi and 2 pi. Oh, okay, that's for sin x equal to 0. Okay, now we're done with the first half. We go on to the second half. 2 cos x minus pi by 6 minus 1 is equal to 0. What do we have to do to solve this? Do we expand out the cosine? Do we do that? No. Why? Because once we have a standard trigo quantity, cosine, sine, or tangent, with one variable inside, and there's nothing else being multiplied onto this cosine. No more multiples. No more multiples. No more cosines. No more other trigo ratios multiplied to it. Then we can just simply leave this alone. What we'll have is cosine x minus pi by 6. You try to make that the subject. You can bring the minus 1 over. You can bring this minus 1 over. So what you have is a 1 at the side. Oh, then there's just now there's a 2, right? So we can also bring that 2 over. So just divide by 2. Okay? Divide by 2. So we have cosine x minus pi by 6 equals to half. Oh, wait a minute. Cosine of something is half. Half is a standard angle. I know what's the basic angle. It's simply 60 degrees. But of course we want radians, right? Pi by 3 radians. Right? Can check with your calculators. Cosine of pi by 3. And of course remember to change to radian modes. Previously we were in radian mode, so it should still be in radian mode. You can double confirm with your calculator. Cosine pi by 3 will give you half. Of course, I won't elaborate on how you derive the angle. The basic idea is you have a 60, 90, and 30 degree angle. You call this length 2, length 1, and the remaining by quadratic is square root 3. 1, 2, square root 3. Then you can work out how do you get cosine something is half, and then the angle must be pi by 3. You can work it out yourself. Then in this case, you have the basic angle is this guy, but you have this quantity being a positive. Can we just simply conclude, therefore x is equal to pi by 3? There's two mistakes with this. First mistake is, no, it's not just an x, it is actually x minus pi by 6. Okay? And if you just stop there, that's still wrong, because we know that cosine is positive. You forgot to think about the ASTC. If we just stop there, it means that we have forgotten to think about the ASTC. So it means that we want to look at the places where cosine has a positive value. It means it's this guy and it's this guy, quadrant 1 and quadrant 4. Right? So we have our quadrant 1, but we forgot about our quadrant 4. That's bad. We forgot about our quadrant 4. So that's why we still need to figure out how to find out our quadrant 4 angle. So again, you have to draw your ribbon. And then you think about how do you get your quadrant 4 angle. Very simple, just draw a line like this. Then this line you have to rotate clockwise 360 degrees. But you exceeded, so you have to subtract a little bit, which is your reference angle, until you reach this point. Then that's how you get your quadrant 4 angle. So in other words, your x, is it just x? No, it's x minus pi by 6. Take the whole thing here. Treat this as one lump. The minus pi by 6 tags along. Okay, so x minus pi by 6 is equal to what? Take the whole rotation, 360 degrees, 2 pi. Then you minus away one of the acute angle, pi by 3. Good. You get 2 minus pi by 3, 2 minus 1/3, which is 4/3, right? 2 wholes is 6/3. 6/3 minus 1/3 is 5/3. Did I say 5/3? I can't remember. Okay, so anyways, 2 minus 1/3 you can always type in your calculator, which will give you 5/3 pi lah. So that's your second angle. But are we done? No, because we need to solve for x, right? So solve for x, you have to do pi by 3 plus pi by 6. Do x equals 5/3 pi plus pi by 6. Type in your calculator. Now in this case, take note, one extra condition given by the question is that leave your answer in terms of pi. In terms of pi means that you cannot simply type in your calculator pi by 3 plus pi by 6. I know if you type that in your calculator, you should be able to get 1.57 something something. But that's not what we want. We want you to factor out the pi. Okay, factor out the pi so that you can have a 1/3 plus a 1/6, like this. Okay, can Then what's 1/3 plus 1/6? That is when you can use your calculator. It's a half. It's a half, which means that it will give you pi over 2. So you sort of treat the pi as if it was a variable. Leave it alone. Then you factor out the pi. You can think of it that way. I think it's convenient. So draw a line to separate. So you got another answer pi by 2. Then we continue to solve. X equals to 5/3 pi plus pi by 6. It's really just factor out the pi, then 5 over 3 plus 1 over 6. Factor out the pi, 5 over 3 plus 1 over 6. What is that? 5 over 3 plus 1 over 6. It's just 11 over 6 pi. 11 over 6 pi. Are we done? Do we stop here? No, we have to check our domain. Right? We wanted answers from 0 to 3 pi. 0 to 3 pi. So do you notice a problem? 0 less than x less than 3 pi. This pi by 2, is it within? Is it inside? Yes. How about this 11 pi over 6? Is it inside? Yes. Yes, it's inside. But wait, what if... here's a suggestion. Here's a wild idea. What if there are more angles than these? Since the standard question is 2 pi, but now, I don't know if you can notice, but usually the questions give you 0 to 2 pi, but now they change it to 3 pi. Don't you think that it's possible that we could have more answers? Yes, correct, we can, yes, it is possible. So that's when I have to modify this procedure a little bit. Modify this standard procedure a little bit when we are solving the angle. At this stage, let me just take out my, use my nifty little selection tool in iPad. I just click and drag this away. I will need to keep this working, that I just drag away, but I have to modify the working at the front part, a little bit. Need to modify a little bit. So what do I need to modify? What I need to modify is at this stage over here and at this stage over here. These two angles are okay. They are okay. But we also need to include 2 pi and subtract 2 pi from these angles. Why can we do that? Because you see, currently what we have when we have, like, for example, this case, x minus pi by 6 equals pi by 3, it means that we have a certain angle that's in quadrant 1, some angle over here. And what about this angle? If you can see, we are starting from the right hand side, we rotate clockwise a little bit, and then we get a pi by 3. But what if we add 360 degrees? We'll get back to the same position, right? If we get back to the same position, it means that it's the same angle. But later on, when you try to solve for x, it will be different. So that's why we have to add on or subtract 360. Subtract means go clockwise to get back to the same position. It will be a same position, meaning it's a same angle relative to the positive x-axis, but it's actually a different numerical value. When you try to solve for x, it will also give you a different numerical value. Okay, so without further ado, the thing that I need to modify is, at this stage, I also need to introduce extra angles. I have to put a comma, and then I consider pi over 3 plus 2 pi, or pi over, okay, I don't even need the equal here, I just put comma can already, or pi over 3 minus 2 pi. But let's be a bit more kiasu. We don't stop there. We also include a pi over 3 plus 4 pi, pi over 3 minus 4 pi. That's a little messy, so let me just rewrite it. Rewrite it a little bit. I want my x minus pi by 6 to be equal to pi by 3 minus 4 pi, pi by 3 minus 2 pi, pi by 3 itself, pi by 3 plus 2 pi, or pi by 3 plus 4 pi. That's one way. Then the other, okay, I need to shrink this down a little bit more. Yeah, so rotate, straight turn, okay. Then after that I proceed to solve it, okay. I try to okay, so we have all these possible angles. Right? We just now we only managed to solve this guy. Okay, we still need to consider these other angles as well. So let's try and see how we can do that. So what we can do here is we can solve for x, right? So all we need to do is to add a pi by 6 to each guy. Add a pi by 6 to each guy means that with an iPad it's very easy. All I need to do is copy and then I paste. There's a minus pi by 6, so I plus pi by 6. Plus pi by 6, I can just copy and paste it a few times. So, but of course, when you're writing it on paper, you have to write it a few times like this. Just to be extra careful, we included a minus 4 pi. Let's just see what happens. Okay. Now, let's just continue solving this, simplifying, and what I will get is, I'll just factor out the pi and I'll get 1/3 minus 4 plus 1 over 6, which is a negative 7 over 2 pi. Straight away, I can reject this. Why? Because if you can remember, it's 0 less than x less than 3 pi. We want positive angles. This is negative, so rejected. But just for the sake of completion, we'll leave it there. We'll write down the answer. Pi over 3 minus 2 pi plus pi over 6, the next guy, is simply factor out the pi. 1/3 minus 2 plus 1 over 6. What do you get? Minus 3 over 2 pi. Next guy, pi by 6, pi over 3 plus pi over 6. That's what we solved already. It's really just half a pi. Then after that, pi over 3 plus 2 pi plus a pi by 6 is just 1/3 plus 2 plus 1 over 6. What does that give me? 5 over 2 pi. Then the next one, 5 pi over 3 plus 4 pi plus pi by 6 is just 1 over 3 plus 4 plus 1 over 6. What does that give me? 9 over 2 pi. Now let's take a look. Previously we only had this as our solution, and then we go and plus 6, and then we got pi by 2 as our answer. Then what we did next is we introduced this minus 2 pi. Okay, I use a different highlighter color just to look nicer. Minus 2 pi, minus 4 pi, plus 2 pi, plus 4 pi. Then we go and plus pi by 6 to each of them, and we get these 4 as our answer. We got those minus 7 over 2 pi, minus 3 over 2 pi, 5 over 2 pi, and 9 over 2 pi. Then we try and check, is it possible that we got more solutions? Let's take a look. These first two answers, rejected. Why? Because it's outside of our domain. Okay, or think of it as the entrance fee. The entrance requirement. You have to satisfy this requirement in order to be considered as a part of the solution gang. The solution is an exclusive membership. You must meet this requirement. It must be in between 0 to 3 pi, then you can enter this solution. But pi by 2 definitely is inside. But what about 5 over 2 pi and 9 over 2 pi? Let's take a look. 5 over 2, of course, is just 2.5. Right? Is 2.5 inside 0 to 3 pi? Yes, it is. 2.5 is less than 3, right? So it must be inside. So it means that we have found an extra solution. We found an extra solution. How about 9 over 2 pi? 9 over 2 pi. Let's check. 9 over 2. We go and add. Okay, we check. It's really just 4.5. Okay, this one outside already. So no, cannot. It's no longer part of the solution. Okay, so pi over 2 and 5 over 2 pi. If we didn't do, okay, so maybe the plus 4 pi was not necessary. This step here, not necessary. This step here, not necessary. But this step here, the plus 2 pi, definitely needed. Okay, so if you don't want to think too heavily about the entrance requirement, I would suggest that you just do these 4 steps. Just write. Or, okay, just write up to, just consider, okay, not write, consider up to plus minus 4 pi. Up to meaning, let me just rephrase that. It means you have to consider the original angle, and then you take original plus minus 2 pi plus and minus, so you get 2 other solutions, and then you have original plus minus 4 pi, so plus minus another 2 answers. So consider all these 5, 1, 2, 3, 4, 5 possible answers when you're trying to solve for x, just to be extra safe, so that you don't have to worry so much about the domain, about the entrance requirement to be a solution. This range of values of x that are allowed as solutions, 0 to 3 pi. Okay, how about the next guy? Our next, same thing with our other solution, x minus pi by 6 equals to 5 third pi. So same thing here, we also have to go through the procedure of plus minus 4 pi, plus minus pi. Okay, so what I'm gonna do is I'm just going to, I'm going to rewrite it manually. It's easier to see. Okay, so what I'm gonna do is I'm gonna consider x minus pi by 6 is equal to the original minus 4 pi, the original minus 2 pi, the original, sorry, I left out a pi here, the original plus a 2 pi, the original plus a 4 pi. Done. Then we bring the pi over 6 over. Okay, this stage I'm going to just copy paste. There's a minus pi by 6. I'm just gonna plus pi by 6, plus pi by 6, plus pi by 6, plus pi by 6, plus pi by 6 to each guy. Then I try and simplify. Now, of course, you see all the pi's, remember, just factor out, okay? I didn't elaborate much on it just now, but I assume that you know already. There's a factor pi, factor pi, factor pi. You can just factor out that common factor. So you ignore the pi and you just focus on the number in front. 5 third minus 4 plus 1 6. You type in your calculator, you get minus 13 over 6 pi. Of course, you can reject that, but let's just write it down for completeness. Same thing here, you have 5 third minus 2 plus 1 over 6. Factor out the pi, then you get minus 1 6 pi. Then same thing here, we already found the solution for this guy. It was 5 third pi plus pi by 6. 5 third pi plus pi by 6. We already managed to find out it is 11 over 6 pi. 11 over 6 pi. Then what about 5 third? Sorry, 5 thirds plus 2 plus 1 6. What do you get? 23 over 6 pi. How about 5 third plus 4 plus 1 over 6? 5 third plus 4 plus 1 over 6. You'll get 35 over 6 pi. Then now, again, we check. Is x in between 0 to 3 pi? Is x in between 0 to 3 pi? This one definitely no. Negative. Negative cannot. 11 over 6 pi, we already checked. It was our original answer. How about 23 over 6 pi? Let's check. 23 over 6. What is that equal to? 3.83. 3.83 pi. Is it still within less than 3 pi? No. Outside already. Then this one, needless to say, it's even bigger than 23 over 6. So confirm it's even bigger than 3.83. Confirm it's bigger than 3 pi, so it's no longer inside. Outside. Outside of the gang. Outside of the requirements already. You're more than 3 pi, so cannot. That means we're only left with this one solution. Okay? Confirm. There's no other solutions. And one more point to take note about this plus minus 2 pi, plus minus 4 pi thing. You should only do it at this step over here when before you go and do any manipulation to this entire block. What do I mean? I mean, you see, at this stage, right, you have a cosine of whatever, and then you try to solve for the basic angle, and then depending on, after you check your ASTC, you realize it's in quadrant 1, 2, 3, or 4, and then you come up with these, you come up with those few possible angles that it could be in. Like for example, okay, I erased mine just now. Yeah, I erased one of the answers just now. For example, one of them is x minus pi by 6 equals to pi by 3. Another guy is x minus pi by 6 equals to 2 pi minus pi by 3. Those are two possibilities. Yeah, so what I'm saying is that at this stage, after you split it up into the two possibilities, I want you only at this stage that to add plus minus 2 pi, consider the other possibility, pi by 3 plus minus 2 pi, comma, pi by 3 plus minus 4 pi, pi by 3 plus minus 6 pi. Okay, but I think usually plus minus 4 pi is good enough. You can stop here. Why do I want to emphasize that? Because later on I'll give you another example where if you don't plus minus the 2 pi, you will miss out on some of the answers, especially when the coefficient of x here is no longer a 1. I'll elaborate more on that with another example. But anyway, so now we have already managed to find all of our solutions. We managed to find pi by 2, 11 pi by 6, pi by 2, our original answer, but we also found an extra 5 over 2 pi as an answer. This is commonly missed out. Why? Because you didn't do the plus minus 2 pi. You didn't do this plus minus 2 pi. Plus 4 pi minus 4 pi. Then you will miss out. Okay? It's especially when they decide to be sneaky and they change the standard angle instead of having an x in between 0 to 2 pi, they change it to a 3 pi. Okay? So that's all. Again, pi by 2, 11 pi by 6, pi by 2 again, that was the same answer, and a 5 over 2 pi. Those are our answers, I believe. Yes, previously that 11 over... Okay, yeah, so also we have to look at this part of the solution. All those answers that are crossed out is not, it's 11 pi by 6. Okay, pi by 2, 11 pi by 6, which is the same as this 11 pi by 6. Then there's a pi by 2 here, which is the same as the pi by 2 just now over here. And our 5 over 2 pi. This is our commonly missed out answer.